Hi guys, welcome to another episode of Solving Business Problems with SQL. And in this particular episode, we're going to be analyzing flight data, and we're going to be using strictly SQL to solving some business questions, answering some business questions here. Stay with me as we go about doing this. We have flight data. We have three data sets in this context. We have the flights, airports, and airlines. And just for context, flight data has like the facts information as regards a particular flight and some attributes that are associated to that flight and delays that are associated with that flight, most importantly, and also cancellations and stuff like that, right? The airlines has like dimensions around uh, the name of the airlines, the ID and stuff. And airport has, the name of the airport, any information related to the airport, right? So let's quickly deep dive into that. I've loaded the data. I've uh, also loaded it into Postgres server, so we'll just be querying from Postgres directly. So I'm gonna just load this libraries again, and then from there I would create my connection to the Postgres engine. All right, so I put the password. Then after that, uh, this one I just this one is just to write the data to the database server, which I've already done. So let's look at the first section, which is flight performance analysis. So the questions here are: what is the average delay time for flights departing from each airport? The average delay time for flights departing from each airport. Second one is: which airline has the highest on-time performance percentage? Now, for this, the flight facts table is going to be used to answer both of them. However, to get the name of the airline, you have to join with the airline dimension table. So let's just get into it. For the first one, uh, say average delay time for flights departing from each airport. So we want to know, okay, let's look at the origin airport, because they said departing from each airport, because that means that the airport is the origin. You have to consider the origin, that is where the flight is coming from, right? So what is the delay in time for the flight that are departing from a particular origin, right? So then we want to look at we're looking at the departure delay. So we are taking the average, say average delay time as mean departure delay from the flight data, and you want to go by uh origin airport, because we want to know for each of the airport. So now then we assign this to a query, and using the read underscore SQL module in pandas, we can then query using the engine, the connection that we have established above. So if I run this now, I would have something. Let me see. I have an error. It's not supposed to be so. Connection to the server, blah 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 field. Password education field for user Postgres. I think I might have entered the wrong password. Let me do that again. Let me do that again. All right. So let's read the query again. So here we are. This is the average delay time for flight departing from each of the airports. So for origin airport 101.35, this is the delay time. We can even sort this in descending order. Say order by one by two, this which is the second column that we are aggregating, descending. So with this we can see, yeah, So you can see that airport with ID 14222 has the highest delay time, which is like 89. I think this is in minutes of seconds. I'm not so sure. So this has the highest delay time. All this from the other airport with negative, it's more like the flight left earlier, right? Which is a good stuff, a good thing, right? Now, in order to identify what's the name of the airport in particular, you might need to interact with the airport table. So we have what we call IATA code. This IATA code is what we are going to join on with this origin airport. Now get the name of the airport actually. So we can modify this query uh, by using CTE, which I find ideal. So uh with what should I call it now? Average departure delay for airport as this. I don't need to sort it yet. Then you now join. Say select a dot star. I'm going to call that table A. I'm going to alias it as A. So from here, I want to alias it as A. But I'm not going to even pick everything. So join airport airport data. I think the name of the table should be airport data. So public schema, airport data, airport data. Let me alias it as B, then say where A dot origin airport. Let me alias this as origin airport. Origin airport. So so that will be A dot origin airport. Airport equals to B dot IATA code. I have to put it in quotes like this because that's how I'll be able to reference that particular column. So I'm not picking A dot star. I just want to pick the airport name. That will be from the table B, which is the airport table. So B dot airport. Let me alias it as airport. Then I'm picking the mean departure delay. Right. All right. Then order by the second column, which is this in descending order. I think we are good with this code. Oh, we are not good. What's going on? So let's see. We have an error. Says A dot origin airport. Syntax error near A. Okay, I did not put the on clause. I guess I did not put the on clause. So say on this. All right. So yeah. Oh, there's something fishy is going on. I did not see there was the airport that I saw before, which had about 89, I think 89 seconds delay is no longer there. That was supposed to be the highest of them. That's weird. So let me do a left join. I think that must have been missing from the data because that's weird. Yeah. So this guy, the airport, the code does not exist somehow the code does not exist, and this also, and that's weird. All right, so this is weird, right? The code can be found in the airport table, uh, so that's why this airport is not showing. So I guess I'll also keep the origin airport name for this particular purpose. So this particular one now. does not have this. Okay, let me sort it by order by three, descending order. So this particular origin airport, the code does not even exist here, so that's why we are having it as blank. All right, so that's on that. Now let's go to the second question, which says airline with the highest on-time performance percentage. Right now, we have to consider airline flights with arrival delay less or equal to zero as on time. When I say it's on time, it means that it's either we arrived at the time we're supposed to arrive, or we arrived before when we are supposed to arrive. Since that means you are on time. So if I have a date and I'm supposed to be at the venue by 7 o'clock, I have to be there on or before 7. By the time it's 7:01, I'm no longer on time, right? So when the delay is less or equal to zero, so if it is negative, it means I arrived earlier, right? So that's how we're going to do that now. So from the flight data, we say airline with the highest on-time performance. So for each of the airline, we want to check uh the number of times. We have to count. Okay, let's say a particular airline had like 2,000 flights, right? We Out of those 2,000 flights, how many of them are on time, right? They will now check it, uh, calculate the percentage by the overall number of flights. That will tell us the number of times they were on time in terms of percentage, right? So again, in some case when the arrival delay is less or equal to zero, then one, it means when it's on time, considering it as one, else zero, that will give us the number of times they were on time. And this one gives us like the total number of flights for that particular airline. Then for the on time, it has to be this number here divided by this number here, right? So that's what we are doing on this third line here, whereby we are saying, okay, the the cases whereby they were on time, want to cast the figure as float divided by the number of flights for that particular airline. Okay, they want to join the information with the airline data so as to know which the name of the airline in particular, right? So let's do a left join also, so that we won't miss out on any airline, probably that the information does not exist on the airline data dimension, right? So let's run this. All right, so we can see that Delta Airlines had the highest on-time percentage with 70%, approximately 71% actually, right? And I think we have about 7 of them that had up to 60% on-time percentage. If I want to approximate, I will say there are about 12 of them. No. We can't approximate 60. Maybe we can. Maybe to the nearest whole number, maybe we can. You can say these are the top 12. These are the top 12 airlines, but we have about 14 airlines, so I don't think I want to go for the top 12. I think I would say maybe above 60. Okay, above 60, we have 5 of them: 1, 2, 3, 4, 5. So Delta Airlines, Alaska Airlines, American Airlines, United Airlines, Southwest Airlines Corporation. Those are the 5 top airlines that had on-time percentage of over 60%. So over 60% of the time, this flight or this airlines has their flights usually on time, which is good because you want to arrive at where you're going as soon as possible. All right, so the next one is like, what's the next question there? Yeah, consider airline flights with departure delay plus arrival. What we were doing is arrival. When I say on time, the question of on time, yeah, let me go there. Which airlines has the highest on time performance percentage? So this one we consider the arrival of the flights that's associated with the airline, right? It means they usually arrive on time. But then we want to now use both the arrival and the departure in this case. Okay, was there a delay in the departure of the flight and also the arrival of the flight? Maybe arrival time is self-sufficient, and the reason I'm saying that is that okay, I'm supposed to depart from the airport by 7 and get to where I'm going by 9, right? But even if the departure time was delayed by 7:30, right? I already zeroed my mind that I'm supposed to get to where I'm going by 9. So if I leave by 7:30 and I'm still able to get there by 9, the departure time will not really matter to me, right? When you departed might not really matter to me again because you took me to where I'm going on time, right? But if your departure affected your arrival, then that is when I was like, oh, it really makes sense. It really matters in this case, right? But then let's consider both departure delay and arrival delay in this case. So we are saying that whenever there's a delay in the arrival, whenever the arrival delay is less than or equal to 0 and departure delay is less than or equal to 0, it means when both the arrival and departure is on time, right? So we are doing the count and then total flight and all. So if we check it and check the result here, we saw that Alaska Airlines is also topping, but it was second here in terms of just considering arrival. But considering departure and arrival, Alaska is topping while Delta Airlines is second, but Delta Airlines was top as regards arrival that is on time, right? So Hawaii Airlines is third, and Hawaii Airlines was kind of where was Hawaii Airlines? Was sixth here. So in terms of both departure and arrival delay, we have like you can consider this top four, which is Alaska Airlines, Delta Airlines, Hawaii Airlines, and SkyWest Airlines. That they would leave on time and they will most likely also arrive on time, right? So if you conclude from the result about that Delta Airlines and Alaska Airlines has the highest on time performance based on the fact that they were both top two in terms of arrival and they were both top two in terms of departure and arrival. That makes a lot of sense. Now, route efficiency. Let's look at route efficiency. And in this case, we want to ask some questions around what are the top 10 most frequently flown routes. And also the second one is which routes have the highest cancellation rate. So how is this going to help maybe passenger decision and stuff like that? So uh, probably also help people that are uh, profiting as regards maybe doing their business in specific routes. If you see that these some routes are usually busy, you want to position your business in that particular location, right? So when I'm talking about routes, it has to do with the origin and the destination airport, right? Where are we coming from and where are we going to? So from point A to point B, that's the route. Now, to know the top 10 most frequently flown routes, I have to do the number of counts whereby the origin and the airport is the number of times that the flights the flights happen there. Now, if we do just this, it's it is it is not sufficient, right? And the reason I'm saying that is that okay, point A to point B, people can travel from point A to point B, and people can also travel from point B to point A. So point A to B, B to A is same route, even though at the point A was the origin and at another point B was the origin. So for instance, this from SFO to from SFO to LAX is a route, right? LAX to SFO is also they are also the same route. So they should be considered as one route that way. So what we're gonna do is this. The best way to go about doing this is to probably maybe one way to do this, let's put it that way. This if I do this now, I have to consider this and the other way around as one single route. So I would say let me use this strategy and say with origin to destination as this. This is going to be 1. Don't let me order it yet. This is going to be 1. And from destination to origin, that's going to be another 1. So I'm going to let me copy this and paste it here. And I'm just going to switch, right? So I'm just using origin to destination. Then SFO LAX is top. Even LAX SFO is also second. I will put first and second. By the time I add it up, you can see that the number is right. So likewise, number 2 and 3, they are the same route. You have to merge them together so to form a single route. So I'll have to switch this has to come here to destination first, and the origin comes here. Then we'll now join the two together. So what we're gonna do is this. We'll now say select route. Sorry, select select. I can just say select origin airport, destination airport. I'll pick it from one of the two. I'll share one of the two. Or one of the two. It's totally fine. We'll have to do a full join because origin to destination, there might be a route that has origin to destination and might not have a corresponding destination to origin, right? So you have to be careful as how we're going to join this before I start selecting it. So I will say select them from origin to destination as A, and after a full join destination to origin, because I don't want to miss out information in both in either of the two. So I'll say on so in this case I want to ensure that the origin, if I'm joining it, I have to ensure that the origin is the destination in the other table. So A dot origin airport, A dot origin airport. Hold on one sec. A dot origin airport equals to B dot destination airport, and likewise A dot destination airport is equals to B dot origin airport. Yep. So now how do I bring those two together? How do I call on those columns? I'll now say I cannot just say A dot origin airport and A dot destination airport and just bring it in. I will say it's when A dot origin airport is null, then use B dot origin airport, then end as origin airport. Then we say also it's when B dot destination airport is null, or A dot destination airport rather is null, then then B dot destination airport, else A dot destination, else A dot destination airport end as destination airport. So I made something here. Case when A dot origin airport is null, then B dot origin airport, else A dot origin airport. Yeah. So then we'll add up the two the number of flights in both of them. So we say sum A dot number of flights. No, I don't even need to use sum. And B dot, that'll be A dot number of flights plus B dot number of flights, and let's call this number of flights. Right. So the order by what? Order by 3, descending order, limit by 10. So don't forget, since these two are top 2, these two are top 2, these two are also there. So the route that we're supposed to be seeing is SFO lax should be top, JFK lax should be second. Then if not it, then what we are doing here is wrong. SFO lax must be top first, JFK lax must be second. Woo! Woo, 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 woo. Where is this coming from? Where is this why are we having none? Why are we having none? Why are we having none? Let me see what we're doing. Where A dot origin airport is the destination airport. Yep, 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 yep. Destination airports and hmm, no way, no way, no way, no way. No way. Uh let's filter. Let's filter. There'll be some cases whereby the let me see. If SFO lacks, so you don't want it to join with itself. For instance, SFO lacks, we already switched it. So if you have SFO lacks, we don't want it to join with SFO lacks. So origin cannot join together. That's where we set it up. So in that case, in that case, mm, in that case, what do we do? What do we do? um okay, let me say instead of ordering by 3, let me filter this first. Where number let me do this. Let me use inner join. Let me see the behavior of this. SFO lacks SFO. Is repeating it. Uh, but it's capturing. It's already adding it together, but it's still bringing this way. Okay, because this is gonna be there. This is gonna be there. I think you might want to use another approach, or perhaps we remove this. Find a way to remove this combination, one of them from there. Let me think. Let's think of something. Uh, oof, ooh. Mm. Okay, let's do a group concat. Let's do a group concat. Ooh, something that will concatenate these two and sort them. So something that can concatenate these two and sort them. We might not even have to do a join. So in essence, SFO lags will be sorted. We have lags SFO. So lags SFO will be in that order. Okay, an idea just came to my mind. So I guess we should do this. What we're gonna do is this. We don't even have to create two queries this way. We're gonna do this. We're gonna do this. So let me remove this second part from here and say that we have already okay. Let me undo. So we already aggregated this part. Now what we're gonna do is this. So we say if you can do something like comparison and say if the origin airport is less than the destination airport, choose the origin airport just to swap, right? So that's what we're going to do now. We now say case, we now say from this OD, say route, sorted route as when the case when case when case when the destination airport, let me start with the origin airport. This when the origin airport is less than the destination airport, then we're going to use the origin airport. Else, use the destination airport. So let's call that origin airport and end as origin airport. Now what we're going to do now, in this case, if I say if lax is less than SFO, it leaves it at lax. But now when it comes to origin airport here, since this SFO is not less than this SFO is not less than lax, it's going to use lax as the origin airport. Now what now happens to the corresponding destination airport? You need the destination airport to also turn around. So we're gonna do this for the so So we want the destination airport to turn around in this case. So case when origin airport is less than the destination airport, we are saying you should use this, right? And case when origin or destination airport, so we're going to turn it around now. Case when the destination airport is less than the origin airport in this case, we want it to use the origin airport, then use the origin airport. If it's less than, yeah, if it's less than the origin, use the origin airport. Else, keep the destination airport. And let's call this destination airport. Right. Then we will now sum this number of flights. Yeah. Sum number of flights. So use sum as this here. Go by 1, 2, and order by 3 descending order. So I don't even need this sorted route or blah blah blah. I think I will just remove this part now. Right. Then let's, oh okay, what's the problem? Origin airport does not exist. Let me see. Origin airport, case one origin airport. Okay, from OD. From OD. So let's do that again. And voila, we have it. We have it sorted. So I think the next thing that we missed is that we want top 10. So I'm going to limit this to 10. 10. Whew. All right, as you can see, lacks SFO. We don't have lacks SFO, SFO lacks. We have met it two and JFK lacks. Yeah. So these are the airports that, excuse me, that these are the routes rather that are the busiest of frequently flown airports. All right. So frequently flown routes rather. Sorry. So which route has have the highest cancellation rates? Now this logic will also apply. So uh to look at this case when cancelled is greater than 0, then flight number, you want to count the number of times the flight was cancelled, right? Uh, then then we now divide by the total number of flights for that particular. So let's see total number of before we do this calculation, let's do the total number of flights. Let's call it total flights for the cancellation rates. Let's call it total flights. Total flights. This is the number of cancelled flights. As you said, route AB is same thing as BE. So we have to put that into context here too. So it's a total number of flights. I just want to count the flight number for that. And we have to merge it, do that logic that we did in the other part. So I would say with let me just give it OD, origin to destination, as this, then is the part we now merge it. We'll just copy the logic from here. We don't have to rewrite it. And the route with the highest number. So here, the cancelled flight, you have to sum this some cancelled flights as number of cancelled flights. Number of cancelled flights. Now, the rate of cancellation has to be the sum of these, right, divided by the sum of total number of flights for that route. Divide times 100, right? So I have to cast this numerator as float so that the calculation will not truncate, not be truncated, times 100. I think that will be it. Then group by, definitely group by 1 and 2, order by 3. No, the rate, the cancellation rate. Yeah, let's order by the cancellation rate. Let's alias this as cancellation rate. Cancellation rate. So order by 4 in descending order. And let's run. Let's run. So we can see now it's unfair. It's unfair to say that this route has the highest cancellation rate. Reason is that the number of cancelled flight is just 1. And for the cancellation rate to be 100%, it means that the total number of flights was also 1. So this route only had 1 flight and that flight was cancelled. It will be unfair to say that this route has the highest cancellation rate, which is not fair. So what I would say to determine this cancellation rate is if the number of flights a particular route has is more than the average number of flights for comparing all the routes. So let's assume that we have 15 routes, 1 up to 15. So route 1 might have one flight, just like this case. These two cases, even the top 4, this fifth one add two number of flights. That's what cancellation rate is 50%, which is even not fair. So what I would say to we will not even consider all these ones that has maybe few flights. We have to consider the airport that has at least a reasonable number of flights. And using the reasonable number of flights we want to use are if the route had flight that is above the average comparing the total routes that we have. So this is how we're going to go about doing that. Okay, we will now say that we now filter say having hmm, having the sum of this, the sum of the total flight in this place we have not even aggregated the stuff yet, so the average will be biased. So let me alias this first as route cancellation. Let me average it from here. Then let me calculate the cancellation rate first. So this number of cancelled flights, then we now have total flights. From here, let me call this total flights. Total flights. And why are we doing this? Now, for instance, it's just like saying now, let me compare it to like football. Let's say a player, you're comparing two players that okay, uh which of these two players has is very good in playing penalty. Let's put it that way. Now, player A had only played 5 penalties in his entire career, for instance. But player B has played 100 penalties. You're not comparing player A with player B, right? Player A has only played 5 penalties, and fortunately for him, he has scored 5 out of 5. Now, you're not comparing player B. Player B has played 100 penalties, and perhaps the first 90 penalties that player B has taken, he has scored everything. Peradventure, the next 5 penalties, or the remaining 10 out of that 100, he now missed like maybe 8, or let's say 5 of them. Then since that player B has scored like 95 out of 100, it means player B does not have 100% record. But player A still have 100% record because he has only played 5 games and he has scored. Uh, he has only played 5 penalties and has scored all 5. Would I now say that player A is better in taking penalties than player B? That's very wrong. That's very unfair. So that's why we will not say that this route EWR and GFK has the highest cancellation rate. It's unfair to say that because this route has only had one flight that has only occurred there, and unfortunately that flight was cancelled. That does not mean that this route can go ahead and have 99 other flights that would not be cancelled. So that's why we are trying to consider only routes that have had like a considerable number of what of flights in this case. All right. So after doing this, we now say okay, for us to consider the cancellation rate and stuff like that, just select this this route cancel, select origin airport and destination airport. Then number of cancelled flights, and let's now do the cancellation stuff here and say uh cast number of cancelled flights as float divided by total flights times 100, right? Total flights times 100 as cancellation rate. Now uh now put a clause to that. Say having no, I wanna say where rather we are not going to consider only routes whereby the number of flights that they've had the total number of flights that they've had is greater than the average, is greater than the average number of flights for that and for the entire route from route cancel. Yeah. Order by what? One, two, that's the cancellation rate. You send the limit by 10. Uh, let me see. It says syntax error near average. Oh, select. All right, great, great. Now we have what we're looking for. So we are considering route DCA GFK as the one that has the highest cancellation rate. Look at this flight. Look at this route. This route has 220 cancelled flights. 220. Even now, if you are supposed to be doing by number of cancelled flights, you will have considered this guy. Look at this guy, 674 cancelled flights. But then compared to the total number of flights that this route has had, it's just 7.8% compared to this one that has 11%. So with this, you can safely say that okay, this route has you can consider these people that as uh, routes to be considered in when you're doing your cancellation rate, right? So comparing to someone that has 100% cancellation rate and is only had add one flight, it's going to be unfair to judge that way. All right, let's go. So the next part is seasonal trend. How do flight delays vary by month or season? What are the peak travel days for a specific airline? There are several flight delays, right? But in this case, we are considering departure and arrival delay, and aggregating by year and month. So and uh, and then we have this. This is the pattern, right? This data only has record for 2015 only. So we have 12 months. We cannot really judge, right? We cannot really judge. We cannot really judge by 1 year alone. If we add more years, then we can look at the seasonal trend, right? We cannot just judge by 1 year. If we look at past year and say that okay, the trend is similar, then we can say that okay, maybe December period, a festive period, there's usually this delay, right? And we can plot this. So let me just pick up something like a chunk of code up here that was used. Matplotlib.py plot, blah blah blah. I think here we are. Let me call this flight delay or something. Year, month, departure delay, blah blah blah. Okay, I think it's fine. Flight delay. Let's call flight delay. And put it here. Plot. Consider X as your month. Since it's just 1 year, and Y as the flight delay. Oh, key error. Key error month. Let me put that lowercase here, lowercase month. Perhaps that's why it's behaving that way. And let me run this again. Oh, great. So this is what it looks like. This is what it looks like. In this case, you might say that maybe uh this is the first quarter, second quarter, the third quarter. So you can say between June and July that there's usually flight delay. you can say maybe because of, I don't know, I can't really translate this to if I want to use Nigeria as a case study, I might say that maybe because it's raining season and stuff like that. That's why we have this spike during this period and stuff. But I want to relate it to the country of that this data was gotten from. I have to relate it to their weather, like within what month do they have that this weather and stuff like that. What happened between this June and July? You might be able to tell why it's significantly high in this period. All right. What are the peak travel days for a specific airline? So this is at airline level. So in order to answer this, we will aggregate number of flights for each day of the week for each airline and pick the top three based on number of flights in descending order. And when we track this, when we pick top three per airline, you can see that uh Thursday is usually common. Look at this airline, Thursday. Look at it's topping the chart. Look at another airline, Thursday, topping the chart. Look at this airline, Thursday, topping the chart. Look at this airline, Thursday, topping the chart. So you can see Thursday, very common, very common. Only this one, Friday, but it's also followed by Thursday. So Thursday is very common. You can see that you can then conclude that Thursday as the peak period for airlines. All right, delay causes. What are the most common reasons for flight delays? So in the flight data, we have several delay attributes, and we are going to be using that in answering this question. Right. So what we're trying to do is that since we have several delay column as in the data, I want to know what are the most common reasons for flight delays. What we're trying to do is that we are trying to merge those delays together, right? And then right? Aggregate the number of times that they occur, right? So you can see that we have air system delay, we have security delay, we have airline delay, we have late aircraft delay, we have weather delay, and the likes. So we are saying when since we want to make them together, so when the air system delay is null, then put empty quote. But when air system delay is equals to 0 also, we have put empty quote, because if it is null and it is 0, it means that there's no delay. We've tracked the whole stuff, right? And we realize that either it is 0 or 1, right? If there's air system delay, it's going to be 1. If there's no delay, it's going to be 0. Else, else put air system, right? Same thing with security delay, and we are going to merge everything together as a single column. They will now aggregate, do a count. So when we're able to do that, this one is just to filter out when there is no delay at all. Because when we have slash 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 slash, like it means that across board, all this delay did not happen. So when we did that, we saw that air system delay was topping the chart with 193,000 times occurrence, right? Then followed by airline and late aircraft delay. We have airline and late aircraft delay. Then the second one was just strictly airline delay. And the fourth one, late aircraft delay, right? Then fifth, air system and airline delay are affected that route. So you can see the top, everything here, and we can limit this to top 10. Just limit this by 10. You can see the top 10. Now, the next thing is how do weather related delays compare to operational delays? And this is the last item. Uh, how do they compare to operational delays? If you're aggregating everything, we want to aggregate it by month in year, right? And and yeah, year and month. It's just 2015. So maybe aggregating by month is just sufficient, but let's just put the year there. And if we do this, we want to order by 7, I think 1, 2, yeah, by 7, which is the weather delay, and see how it is like. And you can see on the ooh, what's this? This is supposed to be sorted by okay, this is in ascending order. Okay, so we say that the weather delay much is the highest on February 2015. February 2015. Security delay is the least of the delays compared to every other delays. Is not really very significant like that. But if you look at other delays, seems late aircraft delay in this last record, late aircraft delay is about 2.1 million. I think it's maybe second. I mean, this is a count rather. This is more like it's a sum rather. 2.9 million seconds in total for that particular year and month. And if you look at it across board, late aircraft delay is usually the highest among them, right? Compared to weather delay, though security delay is the least of them. So comparing weather delay to all other delays, what is topping the chart is the other operational delays. What's topping the chart is the late aircraft delay, then I think followed by airline delay, then followed by air system delay, then before we now have weather delay. So the weather delay is more like the fourth uh fourth delay to be considered when you want to consider delay in any of the flight. And the security delay is the least of them should be worried about. So on that note, we just draw the curtain, and if you have any question, you can always drop it in the channel, right? You can also reach out to me via email, right? And that will be it as regards solving business problem with SQL on this episode. Don't forget to subscribe to my channel and hit the notification bell to have videos like this be notified on your mobile or your laptop, whatever it is, right? And coming up after this video, you should have the next episode on uh building modern data stack, right? Coming up, you should have that video like as soon as possible. So thank you again once again for joining. Hit the notification bell and subscribe to the channel. Bye. Thank you.